Good evening, everyone. Welcome to the Leitner Observatory public night live stream. It's Tuesday night. My name is Michael Faison. I'm an astronomer here at Yale. I'm the director of the Leitner Observatory and Planetarium, where I've been now for 16 years since we opened in 2005. We opened the observatory in 2005 and we opened the planetarium in 2009. And the planetarium theater has basically been idle for the last year. Though we've been doing some upgrades and some maintenance and cleaning and whatnot in the planetarium theater. Planning to open around August of this summer if things go well. Lots of people get vaccinated and pandemic starts winding down. So watch for more announcements about that if we'll be able to open to the public in August or September. In the meantime, I've been doing these Tuesday night live streams just to talk about what's up in the sky, interesting stuff to see with your naked eye or with binoculars, anything in astronomy news that's been interesting over the past week. And if anyone has any questions for me, please put them in the YouTube live chat. And when I see them, I'll pause and try and answer any questions that you have. So if you've seen something in the news, or you're curious about something that you saw in the sky, or you want to know what we do in astronomy here at Yale and at the Leitner Observatory, happy to answer any of those questions. It's somewhat clear tonight. It was a beautiful day here in New Haven. Sunny, a little warm, spring temperatures, 40, 50 degrees. Not quite warm enough yet for me to go out to the observing deck. I'm looking at a live view of the observing deck here behind me, where I have the 12-inch telescope set up with a video camera. And I have I don't know if you can see this, and I might be in the way. I have a star tracker set up on a tripod because a little bit later I'm going to use my digital camera to take some photographs of the constellation of Leo, where I've been tracking the asteroid Vesta. So that's a couple of months long project that I've been working on. Similar to my project to track the asteroid Apophis, right? The Earth grazer asteroid that's going to get close in 2029. As I said in that live stream, there was some news this past week that new calculations of the position of Apophis, based on this recent flyby, based on measuring the positions really accurately, tell us that Apophis is not going to collide with the Earth in the next 100 years at least. Originally there was some thought that maybe it would come really close in 2029, and it is. It's going to fly by really close. And then 2036, who knows? And then 2068 was another flyby that people thought might be close. Now we know with a high degree of certainty that it's not going to hit us for the next 100 years. But there's some other asteroid that we don't know about yet, which may well collide with the Earth sometime in the next 100 years. It won't be Apophis, but it'll be some other asteroid of 100 meter size or 10 meter size or so that'll produce a fireball like the Chelyabinsk fireball. So we have to keep watching for them. We have to keep tracking them. Anyway, it's mostly clear tonight. There's a little bit of clouds, and I thought I would talk a little bit about what's up in the sky this month. We just had the spring equinox a little more than 2 weeks ago, right? Or a week and a half ago on, Saturday, March 20th, we had the spring equinox. So this is when the Earth's northern hemisphere is tilted more towards the sun, so the sun is shining more directly on the northern hemisphere. It's not that the tilt is changing, but of course, as the Earth orbits around the sun, different hemispheres of the Earth will get more direct sunshine. So we're heading into our spring, and the southern hemisphere is heading into its fall. Let's see. There's a trick in the Christian calendar that the full moon after the spring equinox is what's called the Paschal or the Easter moon. And then the next Sunday after the full moon, after the spring equinox, is Easter. So we had a spring equinox. The spring equinox was on March 20th. And then the Paschal full moon was last Sunday. That was March 28th. So we had a nice full moon. So now here on March 30th, we have a moon that's 2 or 3 days past full, so it's going into its waning gibbous phase. And so you'd have to go out around 9 or 10 o'clock, you'll see the gibbous moon rising in the east and then high in the sky at midnight. So we had a full moon on the 28th, and the next Sunday after that would be Easter. So last Sunday was the full moon, so the next Sunday is going to be April 4th. So Easter should be on April 4th. Yes, Fred, don't worry about it. Apophis is not going to hit us for at least 100 years. But as I said, some other asteroid is. So you can sleep soundly if you're worried about Apophis, but everyone should continue to support astronomy research. This is the one few things that astronomers do that have practical value anymore. You know, astronomers used to be useful for telling you what time it is, or for navigation, or for setting a calendar system. And then back in the day, people used astronomers to figure out their astrology, right? Their charts. You don't need to be an astronomer anymore to do that. But these days, the only real practical information that astronomers give us, you know, there's all the space travel stuff, right? But NASA JPL has very precise models for the positions of all the planets and the spacecraft and so forth. So astronomy is less useful for that these days because we have really good models. But watching for killer asteroids and new comets and things like that is something that astronomers are still doing. So let me show you what the sky looks like outside, and then I'll talk about what's up in the sky this week. And then we'll do some live telescope viewing. So if anyone has any requests for anything you'd like to see through the 12-inch telescope tonight, let me know. It's a little bit windy out there, so there's going to be some shimmy to the image. I'll have to see how windy it is when I go out later to take pictures of Leo with my camera, because I need to have a nice steady tripod in order to get that to work. So let me switch over to the control computer that's out on the observing deck. All right, so right now I have the telescope pointed at Sirius, which is just the first object that I pointed the telescope at when I set it up and turned it on and turned on the camera. I was just interested in checking the pointing and the focus. So here's a live video image of the star Sirius. It's a pretty star, especially when you see it through a telescope or a pair of binoculars, but it's not especially interesting through a telescope. Most stars, single stars, are not especially interesting when viewed through a telescope, just because they're tiny points of light. Now, some of them do have interesting color, and some of them are double stars, so that they look like a single star to your naked eye. You look with a telescope and you see, oh, there's two stars or multiple stars there, and that's kind of fun. With Sirius, actually, something that's interesting is that there's a white dwarf companion. So I think it is too close to the star, to the main star. This was a white dwarf companion that was first discovered in 1867, the first white dwarf star ever discovered. It's the closest one, only 9 light years away. And it didn't occur to me, I was just pointing at Sirius to check the focus and the alignment. It didn't occur to me to try and look for the white dwarf. The white dwarf is probably too close to its its companion, Sirius A. I'm pumping up the gain and the yeah, I don't think the seeing and the wind is good enough for us to really see Sirius B, although that's an interesting project. That would be an interesting thing for me to get a student to try, is try and get images of Sirius B, the white dwarf companion of the bright star Sirius A. So in a minute, we'll go look at something more interesting like the Orion Nebula or the Beehive Cluster or an interesting galaxy in Leo or something like that. Actually, we could go take a look at this at Vesta, the asteroid Vesta, if anyone's interested in seeing an asteroid tonight. It also looks like a point of light, but it's kind of neat to know that it's a rock. It's a huge hunk of rock orbiting around the sun along with the planets in the solar system. Now, also out on the observing deck, I have a camera set up that just takes a picture of the entire sky. So here was the latest image from the all-sky camera. And, oh, it's getting a little bit more cloudy. We may not get great observing tonight just because it's starting to get a little bit more cloudy. I can see the Big Dipper up here, and I can see the two bright stars in Gemini. This is almost live image. This is an image I took a few minutes ago using our all-sky camera, which is out there on the observing deck between the domes. You can see the west dome with the 16-inch reflector telescope right there, and the east dome with the 8-inch refractor over there. And I can't quite see the bottom of the screen. It looks like the clouds are kind of over here. I can see sort of the top of Orion the Hunter and the bright star Betelgeuse right there. And there's Sirius, the star that I'm looking at right now. So I'll come back to that in a few minutes. Let me show the let me just show the sky chart here. So here is the latest version of the so-called evening sky map. So this is something I've talked about many times. If you go to skymaps.com, you can download a sky map and a calendar for the month for free. It's updated every month, and here's the version for April 2021. And you can print this out, or you can take it out on your phone and compare it to what you see in the sky. So we're seeing now in April, not surprisingly, the spring constellations, what I think of as the spring constellations. And the winter constellations like Taurus and Orion and Canis Major, the big dog, are all going down in the west and southwest at sunset, heading behind the sun as the Earth continues to orbit in its orbit around the sun. You can see the ecliptic going right across the sky, relatively high across the sky. And the constellation of the ecliptic that are up now, so Taurus is low in the west, and the planet Mars is the only naked eye planet that's out tonight. It's kind of right here between the horns of Taurus the Bull. If you were to draw a line from Betelgeuse to Capella, you would see Mars moving very slowly to the east night after night, so along that dashed line towards Cancer, as the Earth travels way ahead of it in its orbit, and we're eventually going to see Mars behind the sun in a few months. And then we have the constellations of the spring. So we've got Cancer, Leo, Virgo, and then Libra coming up over here. Libra will be coming up tonight around 11 o'clock, 10:30, 11 o'clock or so. The Big Dipper is high in the sky around 10 o'clock or so, so it's kind of moderately high in the sky to the northeast tonight at this moment, as seen from New Haven. The Big Dipper, of course, is part of a much bigger constellation of Ursa Major, the Big Bear. The 7 brightest stars are the Big Dipper, and then you can see some fainter stars that make up the Bear. Some of my favorite parts of Ursa Major are these 3 pairs of stars. These are not true double stars, they're just stars that are seen close to each other. And in Arabic star lore, these are the 3 leaps of the gazelle. A gazelle that's leaping to get away from Leo the lion over here. In Western star lore, these make up the claws or the feet of Ursa Major, the Great Bear. You can use the bright stars in the Big Dipper to find other constellations and stars. So the 2 stars at the end of the cup famously point to Polaris, the North Star, so that lets you find north. The other 2 stars in the cup, so there are these 2 that point that way to Polaris. The other 2 stars, if you go the other way, they point at Regulus, so that helps you find Leo. And then the handle of the Big Dipper, we say that you arc to Arcturus to find this bright red star called Arcturus, a red giant only about 30 light years away. So one of the brightest stars in the sky. I think it's actually the 3rd or 4th brightest star in the sky after Sirius and Canopus. And then if you continue, so we arc to Arcturus, continue to spy Spica, the brightest star in Virgo. Most of the stars in Virgo are not very bright. So if you're a Virgo fan, it's tough to find any of the other stars, but Spica is easily seen even when you have a lot of light pollution. And then I see other later spring constellations coming up, including Hercules, Corona Borealis, and then there is Lyra and the bright star Vega over there in the northeast later in the evening. Vega, of course, is the brightest star in the summer triangle. So we're only a few months away before seeing the summer triangle come back in the evening skies. See if there's anything interesting on the calendar worth talking about. So we have last quarter moon at 10 a.m. Universal Time. So what would that be? About 2 p.m. Eastern Daylight Time. So that is on Easter. So we have a quarter moon on Easter, not surprisingly, a week after the full moon. Moon near Saturn, Jupiter, Mercury. So Saturn, Jupiter, and Mercury are all visible in the morning sky. So if you get up early in the morning and look low, if you have a clear view of the east horizon, get up before sunrise, about half an hour before sunrise, and you'll see Jupiter, Saturn, and Mercury. Jupiter will be fairly bright. Saturn not very bright, about the same brightness as Mercury. And then other few interesting conjunctions with some other stars and so forth. So probably the most interesting thing in April is the Lyrid meteor shower. So this is going to peak on the 22nd of April. We have these annual meteor showers throughout the year when the Earth in its orbit collides with a dust stream of a comet, a short period comet. My favorite of these is the Perseids meteor shower, which happens in August, on the night of August 11th. So expect 10 to 20 bright meteors per hour at its peak. And we have the moon sort of first quarter at this time. So it's not a bad time to go out and look for meteors, because the moon will have set. If the sky is dark, if you go someplace where the sky is dark, you'll see about 10 to 20 meteors per hour, which is pretty good. And shouldn't be so bitterly cold in late April to go out for a meteor shower as for some of the other ones, like the Orionids in December, or the, not the Orionids, the Geminids, or the Leonids in, the Leonids in November. It's a great meteor shower, lots of bright, fast meteors, but very cold always when I go out in the middle of the night. It's best to go out after midnight for any meteor shower, just because you'll see a lot more meteors. On the back of the star chart is objects that you can see with binoculars. So if you have a pair of binoculars and you can go out and look for some of these objects. I'll also demonstrate this in the Sky Simulator here in a second. But there's some nice objects such as M44, the Beehive Cluster. Maybe we'll take a look at it with a telescope in a minute. M42, the Orion Nebula. The double cluster in Perseids is also really nice to see with your binoculars. And you can check off, you can identify all of these stars, kind of like with bird watching. Check them off your list. Make sure you find Procyon, Castor, Pollux, Regulus, and go through and find them. If you have a telescope, there's some fainter targets that you can see, so some fainter star clusters and nebulae and galaxies. April and May is thought of as galaxy season because we get to the time when we see a lot of the galaxies in the Virgo cluster, the Coma cluster, and the, Leo, galaxies in Leo. So maybe I'll show you some of those as well through the telescope. All right. If it's going to turn cloudy, I don't want to spend too much time talking about astronomy news or astrophysics stuff. I'm going to jump into the observing. But I'll mention a couple things, and if anyone has any questions, throw them out for me. There was this amazing image released last week of the polarization, the magnetic field in this black hole image that was released by the Event Horizon Telescope, 2 years ago now. It was like spring of 2019 that this image was released. This is a supermassive black hole that's billions of times the mass of the sun. It's in the M87 galaxy at the very center, which you can see this time of year. So it's right between Leo and Virgo. It's right there on my sky map, the M87 galaxy, and I'll show you in the simulator in just a second. There have been more observations of this black hole as well as some other black holes, and we're waiting for some of the really amazing images, say from the black hole at the center of the Milky Way, to be released. You think the center of the Milky Way is so much closer than the M87 galaxy, which is 60 million light years away. The center of the Milky Way is 30,000 light years away, so 30,000 versus the M87 black hole, which is 60 million. 60 million is a much bigger number than 30,000. But this black hole is so much bigger because it's so much more massive that it's actually easier to see with the radio telescopes that are used to make these types of images of the shadow of the event horizon of the black hole. This news that was released, it's a little bit misleading because it looks like there's a sharper view. It looks like there's a sharper image of the light around the black hole. The black hole, of course, itself doesn't emit black light. It doesn't emit light. It emits black light. But as material is falling in, there's various relativistic effects that boost the light in particular directions and change its spectrum and so forth. So we're seeing light from material around the black hole that's falling in. With M87, we know that there's an active galactic nucleus. And so we're seeing something like this going on. So we have this supermassive black hole right here at the center, a disk where material is kind of queuing up and getting very hot, about to fall into the black hole. And then there are these very strong jets that are, it's labeled here relativistic jet, that are coming out, not out of the black hole, but out from the area around the black hole where it's been heated up to high temperatures. And it turns out that the magnetic field in the gas around the black hole is a big part of driving that material out in the jet of material moving at nearly the speed of light. So this isn't a sharper image. This is just a way of showing where they've measured the magnetic field in the gas. So they've measured the polarization of the light. Is the light going up and down or left and right or in a circle or whatever? That's polarized light. When light reflects off of a surface, it's usually polarized left-right or horizontally, which is why if you wear sunglasses that are polarized vertically, it blocks most of the glare. Polarized sunglasses are really great for, you know, driving or going out on the water, because the light that's reflected off of things will be blocked and you just see the light that's diffuse everywhere. So the light from the black hole is polarized because of the strong magnetic field, and that allows astronomers to see where that black hole, where that magnetic field, which direction is it going and what's the strength of it. So really amazing discovery. I'd say almost Nobel Prize winning work. I would be surprised if the Event Horizon telescope people get a Nobel Prize in the next few years, especially if we get some really nice images of smaller black holes that allow for some tests of predictions of general relativity. So that's really cool. A lot of people have been following the Mars 2020, the Perseverance rover mission. And they're getting ready to allow the Ingenuity helicopter, the drone, call it a drone, I guess. It is autonomous flying vehicle, to allow it to fly. It's going to fly for about 90 seconds or so to do an engineering test, this tiny little helicopter. So it's been released from the rover, and the rover's kind of moving ahead, and the engineers at NASA are plotting, okay, where's the drone going to fly, and then where's it going to land, how's it going to get back, and so forth. So that's going to happen in the next few days. So very excited to get video, images, these amazing in-air views of Mars as seen from the Ingenuity helicopter as carried by the Perseverance rover. Incredibly exciting. Now NASA's really good at the PR with these events. And so I saw this the other day, that here it is. Here it is. This is on space.com. The Ingenuity helicopter has a tiny piece of fabric from the original Wright flyer. The original Wright flyer, it's not that old, right? We've had powered flight since 1903 was the Wright brothers flight. And of course, the original Wright flyer is in the Smithsonian. You can go see it when the Smithsonian opens again. But you can go see it. And so a tiny piece of the muslin from the fabric wings that was used for the first powered flight at Kitty Hawk in 1903 is on board the spacecraft. So that's a really amazing, beautiful, symbolic connection between powered flight on Mars and powered flight over 100 years earlier on the Earth. And it's a tiny, tiny, tiny piece of thread. So it's not anything, they describe the fabric here, it's not anything that's going to weigh it down or is a great loss to the flight or anything like that. It's merely a symbolic celebration of human ingenuity, both in the Wright flyer and in Perseverance. So that's really awesome. Okay, let's go see what's going on at the observatory. So I'm going to switch back to the view of the observatory deck. So there we see the telescope pointing over at Sirius. See the lights of East Rock and some East Haven over there. There's the I-95 bridge way over there. There's Edward Street right along there, so sometimes you'll see some car headlights going up and down. Yale does not have the best campus lighting for purposes of reducing light pollution. There are a lot of these unshielded lights in parking lots up and down Prospect Street and up and down Edward Street. So it would be great if we had shielding on some of these lights to give us a better view of the night sky when we have students doing research or when we have public night, when we have visitors come up. Wouldn't make a huge difference, but it would be nice. It'd make a huge difference if the whole city had better light pollution prevention policies, but New Haven is so-so when it comes to that. All right, let's see what the telescope is seeing now. Or actually, before we do that, let's take an all-sky image and see what those clouds are looking like. So I'm going to snap a new image with this all-sky camera. This is just a camera with a fisheye lens. It's pointing up at the sky. It's connected by USB to this computer. Oh, hey, it looks a little better than it did earlier. So let's try to take some pictures here. So I can try and point out the star patterns that I was seeing earlier. There's the Big Dipper right there, right? So there's the two stars in the cup. There's the handle, and those two stars in the cup point to Polaris, the North Star, right there. There are the two bright stars in the Little Dipper. Most of the stars in the Little Dipper are too faint to see if you have any light pollution. You have to have really dark skies to see all of the stars in the Little Dipper. And then over, sort of overhead and also to the south, I see the star Capella over there, the bright star in Auriga, that pentagon-shaped constellation. And I see, oh, there's either an airplane or a satellite. It's blinking, so it's probably an airplane. And there is Pollux and Castor, the two bright stars in Gemini. There is Betelgeuse, the bright star in Orion, right down there. And I don't see Arcturus is kind of in the behind the dome and in the trees. That could be it, sort of just rising above the dome right there. So what I'm seeing here is Cancer would be right in here. And then here's Leo. This is part of the constellation of Leo. Oh, yeah, I see all of Leo right now. So there's Regulus, and there's the stars at the back of Leo. Yep. Okay, so let's try to point at something interesting that'll be obvious. Maybe we'll try pointing at the Orion Nebula to start with, since it's getting lower in the southwest, and we maybe only have a few more weeks to view it with telescopes before we lose it for the season. So let's move the telescope over to the Orion Nebula, also known as Messier 42. All right. And there it is right there, the sword of Orion. Let's slew the telescope. And I am going to switch my camera mode here so we can take longer exposures. We're going to do this live stacking mode for the video camera. All right. And we're connected to the camera and cooling the camera. Try a 10-second exposure here. If we were to look at the camera again, if we were to look at the observing deck, the telescope is kind of moved to the west and a little bit south. And there are trees over in that part of the sky, so we might have a little bit of a blocked view of Orion. Over the next few months, as it's warmer, I'll do some live streams out at the observing deck so that I can point things out in the sky, and I can maybe do some demos, hands-on demos with a telescope, sort of how to use the telescope, how to find things, that kind of thing. Oh, Fred's saying that the ISS passed over. Yeah, that didn't look bright enough, or the thing was, it was blinky. So the ISS is really bright. It's about as bright as Venus. So you really know when you see it. And that object was blink. I saw it where it got bright and then fainter and brighter and fainter. And that's usually an airplane. You can see an airplane going by right there. That could well have been the same one, since it's going in the same direction. There's an airplane over in the upper corner of the deck cam. Okay, let's see if the Orion Nebula is there. Spying the space station is kind of a fun hobby for amateur astronomers. You can go onto websites like Heavens Above. If you go to heavens-above.com, it will tell you when the space station will be overhead at your latitude, and you can run outside and watch and wave, wave to the space station. There's also an amateur radio transceiver on the space station. And I do have a radio and a ham radio license, so I've been wanting to try to communicate with the space station. There are a couple of different ways you can do it. So that's a project I'd like to try with my summer students sometime. Okay, so let's see what the camera's seeing now. Hey, there it is. It's a little blurry, and maybe the focus is a little bit off. See if I can improve the focus just a little bit. But there it is. And let's adjust the brightness and contrast a little bit. There's the Orion Nebula. I can tell the focus isn't perfect because the stars are a little bit blurry and they've got a little bit of color around the outside of them. And they're not so out of focus that they look like donuts, but they're a little bit blurry. So I don't know how much time I want to spend on trying to get better focus. We'll see if that improves it. Let's start over. Let's clear that. Yeah, I think that's a little better, but it's still a little bit out of focus. So I'm not gonna fuss with it too much. I will move the telescope over just a little bit. There's what we're looking at, and let's actually change the orientation here. There we go. So there's the nebula that we're looking at. This is not an image from the telescope. This is an image on the star chart. So I'm going to move, I think I want to move this way a little bit. Yeah, that's the way I wanted to move. So let's clear that. There we go. Yeah, so it's a little bit out of focus. It's a little bit blurry because of the wind, but you can definitely see what's going on here. So we have these 4 hot, luminous, massive stars here right at the center of the nebula that are putting out a lot of ultraviolet light, ionizing the gas cloud around it. The Orion Nebula is a star-forming region. So it's a place where new stars are formed. It's a cradle of stars. On the inside of the Orion spur of the Milky Way, which is what we see when we look in the direction of Orion and Canis Minor and Taurus. There's a big cloud of dusty material, dusty gas, and sometimes it's cold and dense enough that it starts to collapse under its own weight. The heat, temperature, the pressure from the heat doesn't hold it up, and so it starts to collapse under its own weight, which causes it to get hot very quickly. The core gets so hot that it turns on nuclear fusion, that blows away the rest of the gas, and you end up with a star or a little cluster of stars like we have right here. So you can see that little cluster of blue stars right there. Now, let's see if current image is ignored, stack finished. I'm going to try to combine some images here. We'll do slightly longer exposures. Okay. And we have the cooling. Something that's great about these video cameras, you can cool them down to well below 0, and that helps reduce the noise that you get in the image. Okay, let's try that. It's a beautiful object to look at with binoculars or with a small telescope. Probably my favorite winter object, the Orion Nebula. You don't see the color. When you look at it with your eye through a telescope, you don't see this nice red color or this nice green color from the glowing gas. But you can definitely see the fuzz. You can definitely see the dust clouds around the nebula that block the background light. So it's kind of satisfying. As I was saying a minute ago, the reason the nebula is glowing is because the light, the ultraviolet light from these young, massive, hot, bright stars is ionizing a big cloud of hydrogen gas around it and making it fluoresce, just like gas in a fluorescent light bulb or neon gas in a neon sign. Okay, well, let's look at one or two more objects tonight before we get clouded out. I'm going to look at the sky camera again, take another picture, do a slightly longer exposure. The all-sky camera is nice for just checking to see if it's getting cloudy or getting less cloudy or more cloudy. Because we've been doing mostly, actually all remote observing with students lately, you just have to know if it looks like the clouds are getting better or worse, and you can't just go outside and look because the students are doing remote observing. I think it's a little better than it was before. All right, so I think maybe we'll go look at maybe the Clown Nebula over here in Gemini, and then maybe the Beehive Cluster over here in Cancer. So let's try that. So we'll stop this. All right, and clear that. And we will go to the Clown Nebula. So this is a planetary nebula over here in the constellation of Gemini. So here we go. So the telescope's moving. Let's watch it on the live video. There's the telescope moving. It was kind of lower in the west, and now it's moving to the east and to the north. The telescope looks really short and squat in this video feed. That's partly because the video doesn't have quite the right aspect ratio. It's kind of stretched horizontally. Also, the telescope is kind of foreshortened because it's kind of looking down. And then the other thing is that this is a Schmidt-Cassegrain type reflecting telescope. So there's a mirror at the back of the telescope, a mirror at the front of the telescope. The light comes in the front, bounces off the 12-inch mirror at the back, goes back up to the front, bounces off of another secondary mirror, and then goes all the way back. And then the video camera is right there. That's where the light gets detected and measured. And that's where we can make an image. Okay, let's see if we can see the Planetary Nebula here. All right, so we're going to do, 30 seconds. I think we're gonna making a few small changes here and there. Okay, so let's go ahead and start. Hey, there it is. It actually looks great even when it's not perfectly in focus because it's a little fuzzball. It's a little green fuzzball. Let me reset the stretch here. It'll look better after a few images have been combined. Yeah, that looks better. Yeah, I think if I were to spend about 20 minutes messing with the focus, I could probably get the focus a little better. So I can make the stars look a bit sharper. Oops, come back. Oh no, my software crashed. All right, let's start again. Okay. 30 seconds, cooling. Okay, start. We'll have to wait 30 seconds to get an image here. So I'm probably going to sign off in 10 or 15 minutes, so I don't think I'm going to work on the focus too much. Although if I go take pictures of Vesta, this asteroid Vesta, I would maybe need to have better focus. Hey, there we go. So this is what's left over after a low mass star dies. So a star like the sun. The sun is going to look like this in approximately 7 billion years or so. What will happen is that the core of the star collapses to form a white dwarf, this very dense stellar remnant that's left over from a low mass star core, a star nucleus. The core of a star is very different from the rest of the star. The core of the star is very hot, 15 million degrees, very dense, maybe 100,000 times the density of water, very high pressure, and that's where nuclear fusion is taking place. That's what provides the power to hold the star up and to provide the trillions of let's see, it's going to be millions of trillions of watts of power that come from the sun, for example. All comes from nuclear fusion, hydrogen fusing into helium and producing power. So that's happening in the core of the star, but that can't last forever because, of course, eventually the core will run out of hydrogen. So the core starts to run out of hydrogen, it shrinks a little bit, that makes the outer layers get bigger, it shrinks a little bit, that makes the outer layers get bigger, and you end up with a red giant star like Arcturus. Eventually the core of the star can fuse helium into carbon. That's another way of producing energy. But even that's only going to last about a billion years for the sun. About 10% of a star's lifespan is fusing helium into carbon. So the first phase, 90% is hydrogen into helium, and then 10% is helium into carbon and oxygen. And then the core of the star collapses to make a white dwarf. The outer layers blow away to make this nebula called a planetary nebula that looks just like this. Let me actually adjust the background so it looks a little bit more clear what you're seeing. And what you're left with is the core of the star makes this remnant called a white dwarf. You can see it right there. And then the outer layers blow off to make this shell of ionized gas called a planetary nebula, which will expand and cool and fade. They tend to have these distinctive colors of reddish, a reddish glow from hydrogen gas and a bluish green glow from oxygen gas and a yellowish glow from sulfur gas. And there's a few other colors that are associated with these planetary nebulae. But that tells you actually that heavy elements, well, I say heavy, elements needed for life, elements heavier than helium. You can't make life out of hydrogen and helium. You can make a galaxy, but you can't make a human or even a microbe out of hydrogen and helium. So carbon and nitrogen and oxygen, the building blocks of life, are made in the cores of these low mass stars. The star explodes and those elements become available to future star systems to form planets and the building blocks of life as we know it, right? Hydrocarbons, hydrogen, carbon, and oxygen. Amino acids that contain hydrogen and nitrogen and carbon, and so forth, the sort of building blocks of life as we know it. Let's take a look at the Beehive Cluster, and then I think we'll stop for tonight. So let me pause this, and let's move to the M44 Cluster, which is also known as the Beehive Cluster. Okay, it's right overhead. As long as I have the all-sky camera on, let's take another picture. Something else that the all-sky camera is useful for is for monitoring meteors. So yeah, I will actually use this when there's a meteor shower to take pictures of meteors over the course of the night. Yeah, it looks pretty clear, so I think I will try to take pictures of asteroids a little bit later tonight. There's some clouds over in the southeast, but it's not too bad. So let's go take a look at the star cluster. The star cluster I'm interested in, I can almost see it if I took a longer, let me try a slightly longer exposure here. And I'll adjust the background. This is a star cluster. You would be able to see if the sky is dark where you are, almost with the naked eye, but certainly with a pair of binoculars. It's in the constellation of Cancer, which is between Gemini and Leo. And I'm really struggling to see, I can see Cancer. So here are the two bright stars in Gemini. There's Pollux and Castor. Here are the bright stars in Leo. The asteroid I'm interested in, Vesta, is right about there in the sky right now. And there is Cancer. So it's that star, those two stars, that star. And the cluster we're interested in is right between those two stars. So the Beehive Star Cluster. Young star cluster, basically what you see after a star-forming region like the Orion Nebula has made a cluster of a few thousand stars and the gas around it has dissipated and the stars have drifted away from where they formed as we all orbit around the center of the Milky Way. All right, let's go take a picture of the star cluster. Oh, first we have to move the telescope. So let's move the telescope from the Clown Nebula to the Beehive Cluster. And if I jump over quickly to the, there we go, there's the live video of the telescope moving. It's going to point more or less overhead, a little bit south of directly overhead. One of the things about the design of this telescope mount is that if you want to go look at something over in that part of the sky, what would be over towards the east, is the telescope would have to point to the north and then turn over and then point so that it doesn't collide with the telescope pier. All right, so there are different parts to this telescope system. There's the pier, which is permanent. The mount, which is this huge piece of aluminum with electronics here, which points the telescope at the desired location and has it track the sky very accurately. And then there's the telescope, which has the glass and the mirror surfaces and so forth. The telescope is mostly air, it's mostly empty. And this telescope is not very big or heavy. So this mount is way over supportive. It's overkill, it's too much for this little telescope. Usually we have a bigger telescope that we would mount on this. And in fact, I think, yeah, it's the same, our 6-unit telescope, which is in the West Dome, is mounted on the same brand of mount. This mount is eventually going to go to a remote site in northwestern Connecticut. Remote site. There's no part of Connecticut that's remote, but a dark sky site so that we can do some remote observing under dark skies. Okay, let's go look at the star cluster. Yeah, that's where we're pointing. Let's take some pictures. The star cluster is going to be bright, so we don't need such long exposures. We'll switch to 10-second exposures. There we go. All right, so it's a little bit off center, so let me move the telescope a little bit. So we'll nudge over the same amount we did before. I think I need to do a new pointing model for the telescope so that it knows exactly where to go in the sky. And if we stop and take some new images. So there's the motion. You can see the streaking of the telescope moving. There we go. Now we're zoomed in on a small part of the star cluster, but I can see these sort of distinctive triangles. I always recognize that in the Beehive clusters. This little triangle down here and this little triangle up here. Let me adjust the background. We'll start comparing images. And I'll show you what this looks like in the simulator. So here's the sky right now in the Stellarium sky simulator, right? And so we were looking at the Orion Nebula over here in the Sword of Orion, and then we went and saw the Clown Nebula over here. So you can kind of zoom in and see there's what it looks like with a sharper telescope. And now we're looking at the Beehive star cluster right here. So it's quite a large star cluster, and we're basically only seeing these stars and these stars. We're kind of seeing this part of the star cluster. If you have binoculars, you can see much bigger area, right? So this is a nice object to start with if you have a small telescope or binoculars to find in the spring. It's a nice object to start with for astrophotography. You just put your digital camera on your small telescope You don't have to take long exposures because it's very bright. So great object to take photos of. It's fun to observe. Yep, there it is. Now you can see a little bit of variation in the color, right? So actually, if we adjust the color here, didn't make a huge difference. Yeah. So these two stars are kind of bluish, and this star is kind of yellowish. That star is kind of yellowish, bluish. So star colors are determined by the temperature. So a blue star is much hotter than a red star. So the surface temperature of the star, the surface temperature of the star is what determines its color, from bluish to whitish to yellowish to reddish. There is no such thing as a green star or a purple star. The light doesn't combine in those combinations to make those colors. Stars are glowing because they're hot, because of that nuclear fusion going on in the core. And you would never see something glowing purple because it's hot. That's physically impossible. If we ever saw a green star or a purple star, that would be evidence of alien technology, not a natural ball of hydrogen gas that's glowing because it's hot. In these star clusters, you know that all the stars are at about the same distance from us. I think it's about 100 light years for the Beehive Cluster. You know they're all about the same age. They formed at about the same time from the gas in the Milky Way galaxy. So the stars that are hotter are probably more massive stars. You know, more mass produces more pressure, produces more power. So those stars are brighter and hotter, and that tends to be the case. We've learned a lot about the lives of stars, the lifespan of a star, by looking at these star clusters and looking at star clusters of different ages. In fact, why don't I do this? There's a star cluster, this is a very young star cluster, but I know of a star cluster close to this one in the sky that is quite a bit older, and that is the M67 Star Cluster. So there's M44. The M67 Star Cluster is kind of over here. So we can quickly go point at it, and I can show you an old star cluster along with a young one. All right, so it's right down there. So let's just nudge the telescope down a little bit and take a look at it. I love looking at M44, the Beehive Cluster, through our 8-inch reflectors here on public night. Really beautiful glowing stars like jewels with very subtle colors. So it's a really nice target to see. Okay, so there's the streaks from the other star glowing. So here is an old star cluster. This is, and let's do actually a longer exposure because it's quite a bit further away, so it's quite a bit fainter. So we'll clear that last image and start getting some new ones. So this is a much older star cluster, and the stars are fainter, the stars are redder. What's happened is that the high mass blue bright stars have all died. They've all gone supernova. And what's left behind are the low mass stars, more like the sun. The sun is actually a low mass star. And even then, they're relatively old. I think the star cluster is 8 or 9 billion years old. And so the stars that are there, the brightest stars, are these red giants, which are approaching the end of their lifespan as stars. And they're going to form planetary nebulae, like the Cloud Nebula earlier, in the not too distant future, in the next few 100 million years, not too distant future. Okay, well, so it's 9:30. I'm going to stop the live stream there and see if anyone has any last questions about astronomy or what's up in the sky or star clusters or anything like that. Like I said, when it gets warmer, my plan is to go outside to the observing deck more and host live streams out there. I want to do a few sort of how-to videos or some guidance videos on how to use a telescope, how to find things in the sky when you're looking at the sky, things like that. So you can follow along with me if you have clear skies where you are. We have another guest speaker coming up at the beginning of May, so I'll make some announcements about that a little bit later on as well. All right, well, thanks to everyone who tuned in today for the live stream. Really appreciate it. Love to get your comments and your questions. It's nice when it's clear and so we can go look at stuff through the telescope. Let me know if you have any questions. So my email address is michael.faison, so that's Faison, at yale.edu. So feel free to send me an email if you have questions, or if you have suggestions. A few people have sent me emails asking questions about using telescopes and things that they'd like me to talk about. I'm happy to do that. The Leitner Observatory website is leitnerobservatory.yale.edu. And if you go to that website, you'll see upcoming events that are live stream events and more info on when we might be able to open up to the public. In the meantime, I hope everyone stays safe, right? It's not time to let our guard down. It's time to stay safe till everyone gets vaccinated and everyone's healthy. Stay safe. Have a great Easter weekend. Clear skies and nice weather to everyone. And I'll see you next time. All right. Good night, everyone. So long.